So as the name suggests, polymer compounders, we are a thermoplastic compounder of materials. We are based up in the northeast in Durham, not too far from a very large automotive plant in Sunderland. A lot of the materials that we use are PCABS, ABSs in large volumes for the automotive industry, which like large volumes of black materials. So very simply, compounding can just be adding pigments to relatively common standardized materials. More often what we do though is trying to make bespoke compounds, so to custom engineer the materials to do exactly what the customer requires. We have an R&D facility where we can start to do some more exciting developments with the materials, so blending different materials and then really targeting special developments for new legislation. Apart from automotive, yeah, we also do various different other markets as well, the medical industry, healthcare, and a little bit of transportation as well. But for the purpose of this presentation, we're talking about flame retardant materials. Just to clarify, for injection molding and extrusion, the most common flame retardancy rating that we'd be looking for is V0 UL94 test. The flame is going to extinguish within 10 seconds and there can be no burning drip. So that's really what we're trying to achieve with any new flame retardancy development. If we look at two of the most common materials that we're involved in, and some of the materials that you or your molders may be using, ABS, PCABS, fairly standard materials. If we look at the flame retardancy that's involved in both of those materials, and two completely different technologies. In FR-ABS, we're obviously concerned about the halogenated systems that are still used in those materials. So that is obviously a concern. A lot of bromine use, which is something that we'd like to move away from if we can. It's not only just the bromine that's in there that causes a problem, but there's lots of other toxicity concerns around those compounds to get the flame retardancy of ABS to the V0 level, which is a big concern for everybody at the moment. The next logical step then would really be, if you need a V0 product and you want to be a bit more environmentally conscious perhaps, or look at less toxic or non-halogenated materials, would be then to move to an FR PCABS. Polycarbonate in there has a little bit of inherent flame retardancy, so therefore we can use less toxic, less strong flame retardant packages, which is good, but now we're finding that a lot of those systems are causing problems with regards to human hormone disruption. A lot of studies now showing that the toxicity is affecting things like aquatic life as well, so not good, getting slightly better, but then we're seeing a lot of studies coming on now which are showing that those different flame retardant systems are potentially just as bad as well. This story is not something new, it's something that has been evolving since the 1970s. So a lot of the materials that we use in the early days is PVDs, and a lot of brominated systems, quite nasty, aggressive flame retardant systems there. A lot of those have been banned now, but there still is one or two hanging about, and unfortunately TBBA is still the most common flame retardant package that's used in ABS. I'll come on to that, why we think the writing is on the wall for that material shortly. So moving up the chain then to, if you're holding PCABS, then these flame retardant compounds of RDP, BDP, better, but still now the data is suggesting that those are quite harmful to human health, and more and more studies which I'll show you are pointing the finger at those. We think that those will eventually, the next one is in the firing line for restriction further down the line. And then moving up, trying to look at what we as a compounder are trying to do to look at the next generation of thermoplastic and flame retardant materials. So these are just 4 studies, 4 news articles that have been published just in the last month, really. A lot of stuff has been happening over the years, but just in April alone, Environmental Science and Technology magazine highlighted that some of these flame retardants that are used in automotive seats and foams are leaching out of the foam in the seats, and just by skin contact alone, getting into our bodies just from direct skin contact, causing hormone disruption and even cancer. CNN News mentioned also in April that thousands of consumer products have been linked to cancer. First time. Newsweek, toxic chemicals in everyday products. Again, just via touch. So not even talking about when the product burns or breathing in toxic fumes, it's just direct contact and touch with flame retardants or flame retarding plastics. Science alerts again in April, toxic flame retardants, coming into contact and getting into our bodies just through the skin. There's not an awful lot of coordinated legislation at the moment, so industries are trying to do what they can on a case-by-case basis. So, for example, in the US, New York and Washington State have banned flame retardant ABS from displays, TV monitors, those other things, because of this inherent toxicity of the material. The medical industry has their own phase-out programs to try and reduce the amount of flame retardant materials that they're using in their industry. And the European Chemicals Agency have recently now just added most of the common flame retardant systems that are using ABS and PCABS to their substances of concern list. And then the next step after that, the FR additive for ABS has now been placed on the substance of very high concern list. And then the next stage after that will most likely be a ban. So when that will be, we don't actually know, but you could estimate maybe in the next 12 months that something like FR ABS may be becoming increasingly difficult to get hold of, because suppliers will start to restrict the supply as consumers and OEMs start to move away completely from something like FR ABS. And if you don't believe me, why should you? We're only a polymer supplier. Never trust what they say. But you can go to the ECHA website yourselves and have a look. A screenshot directly from the European Chemicals Agency website, which lists then all the chemical names, and my God, what a mouthful, but that top one there is the main active flame retardant system that's used in ABS. And as you can see there, what's highlighted in the red circles, they are suspected of causing cancer, they're persistent, the bioaccumulative toxic. That means once they get inside the body, we can't clear them, so they build up inside the body. And ED means they're now a confirmed endocrine disrupting chemical within the body. So that's the situation in FR-ABS. As we mentioned, PCABS is that next logical step. I think maybe moving to something slightly better. And you are in some respects, but now all these packages that are used in FR-ABS, BDP, RDP, etc., all contain trifluoro phosphate, and that is now, a priority for the ECHA to study further, because this TBP is now confirmed it definitely is an endocrine disruptor, as of a French study was completed in March this year. Not only toxic to us, but toxic to aquatic life, and when it gets into water courses. And there, the summary at the bottom there, the bottom line really is that most of the flame retardant systems that we're familiar with today are at risk of being removed from the market. So it really is quite a dire situation. And again, there's the evidence from the European Chemicals Agency website that RDP, contains triphenol phosphate and is an endocrine disruptor. So is there a better way? What else can we do? Because unfortunately, if you bought a washing machine, an iron, a high heat domestic appliance within the last 15 years, then I guarantee you've got all these toxic materials in your house. We've all got them now inside our bodies as well. It really is something that we would like to try and avoid if we can. So we've been playing with a new breed of materials and really technically not actually a flame retardant additive, also a highly flame retardant polymer system. So these polyphosphonate co-carbonates found extremely good flame retardancy, absolute minimum toxicity and impact on human health. Found that when we blend this polymeric system with PCABS and PCASA, can match the current sort of properties of existing flame retardant materials in terms of mechanical impact, flow, but with far less impact on human health. So it's a halogen-free, triphenol phosphate-free. We really think this is the sort of future where the industry should be looking. The properties were so good that we thought we can rebrand this whole product as what we call Notoxicom. We actually granted a UK patent this year for this product. So to explain in a little bit more technical detail, I'll hand you over to Stephen, our technical manager, who will just take you through the technical sides of this as well.
So we developed a product along with our partners at Retardants to have a material which is completely additive free in so much that there is no flame retardant additives in the product. It's 100% polymeric. It's absolutely non-migratory because there isn't any chemicals in the product, and it has a much more, you see, a favourable toxicity profile. But one of the things as well that Richard mentioned is, not only do we think that it has a properties profile in terms of its mechanicals that is similar to most of these products, in a few categories it's actually superior, especially in light weighting. I'll go into that later on. So what the market is looking for is obviously materials that are in the top left corner, and the product that we have at the moment meets every single one of these CTQs, for want of a better word, critical equalities, that is on this list. So basically, we think it's almost entirely positive with very little, if any, negatives for what we've saw. And hopefully these results will show that to be the case. So in terms of heat performance, for example, usually the liquid phase that goes into the flame retardant PCABS, as well as obviously containing those toxic materials, also has a plasticizing effect. It reduces the thermal performance. Our product, 100% polymeric, keeps that thermal performance. So we have a VICAT that's 10 to 15 degrees higher than most of the FRPCABSs on the market. Its impact is 46 kilojoules per metre squared, which, as we are a massive automotive supplier, we know that is high enough for vehicle crash tested interior. Their non-FRPCABSs, which have been crash tested, is at the level of this impact result. We've got a halogen-free V0 rating and also a 5V rating in all colours. That's been approved by UL, as you see as well. It meets glow wire flammability at 960, but as I say, it also has a lightweight advantage. Also, FRABS has an SQ 1.2, FRPCABS has an SQ 1.2, FRPC has an SQ 1.2. Our product, our B6000, has a tested SQ of 1.14. So in terms of lightweighting, it's also got a large advantage as well. So to summarise, as I say, no drop in heat performance, lower density, it meets aircraft smoke toxicity. So we got it tested for interior for aircraft smoke toxicity, and as I can show you these results, sorry, I'll just go and get the toxicity results. As you can see with these results, it actually passes by miles smoke toxicity for aircraft interiors. These were the specifications here, and these are our results. So as you can see, in terms of some of the results, we get 0 ppm, 5 ppm, and passes smoke toxicity for FAR 25 in aircraft interior. So we also, as we say, looked at its recyclability. We looked at it very much against the products of BPADP and RDP based rates, and we looked at its impact, and we also looked at its flame retardancy. And what we see with this product as well, because it doesn't contain any additives, it remains, the matrix isn't changed by recycling. There's nothing to devolatilise, nothing to leach out. So what we found in terms of recycling is that the product remains robust in terms of its V0 rating after recycling as well, compared to the products that we have at the moment. Sorry, this is very sensitive. We also just some things like glow wire and GWIT and also CPI, just so the types of markets it's used in, so people can see that if they're using an FRPC ABS at the moment, a traditional one, you can see that our Notoxicom product is very compatible in those type of properties as well. Sorry, this isn't private, this is. Yeah, this is just images of these tests getting done. Every single test result you hear here has been externally tested. They're not polymer compound delivered and tested, internal data. These are data that's been sent all over the world for different test houses to test the product, as you can see in this case. So back to the toxicity again, which is obviously the core property of this product. Smoke inhalation is the main cause of death, and so therefore toxic smoke will all be about the materials going to farmhouses, and it's not the flame that kills you, it's the smoke. Going back to this smoke toxicity result, we are massively safer than anything that's available in FRABS or FRPC ABS in terms of what actually happens when the product does go on fire. There's basically nothing of concern coming off. So just a vertical burn demonstration we have. The Notoxicom product in the middle was tested side by side against these, and there's a massive reduction in brown to black smoke and effects like that coming off when it actually does start the combustion process, which is very quickly eliminated. It's just a quick demonstration of the lack of smoke generation and stuff like that when this product actually runs. And you see how robust it is in terms of flame retardancy. So finally, to finish on the product, this is your yellow card that, as you can see, has been very recent in terms of us giving the V0 and the 5V rating on the product in all colours. So basically we can make it in all colours. I note as well, in white colour we also have a V0 at 1.5mm mass in the product. We've got that tested separately from the rest. So we immediately use it in terms of its UL compliance. So to summarise, TBBA is highly likely to be removed from the market after major health concerns. It went on the Substances of Very High Control list in January 2023, and it will be very quickly removed from that, and that basically is the end of FRABS. FRPCABS contains liquid flame retardants that contain triphenylphosphate, which, as Richard showed you, is also a product which is going to be very much under the same type of spotlight as the halogens are at the moment. And our polyphosphate carbonate technology provides a safer solution for these, and also containing mechanical properties, but as you saw in a few cases, superior mechanical properties. And what Richard has at his side to show that the product is real is this is a battery casing made in green colour and in black colour from our Notoxicom product. Thanks very much for listening, everybody. Thank you. Do you have any questions? Anybody got any questions on the product? Okay, thanks very much.